Hi, this is Mr. Block from MrBlockTutorsMath.com. And I was talking to a student. We were talking about, or he was talking about infinite numbers, very large numbers. I mentioned to him that many fractions are infinitely repeating. And his comment, well, we looked at 1/3, 1/3, which when we divide 3 into 1, as you all know, we get 0.3 repeating. So in other words, the threes just keep going and going and going and going and going. And his comment was, how do we know that the threes don't eventually add up to more than 1/3? How do we know that? So I said, well, let's look at that distance between 1/3 and approximations of 1/3, for instance, and see what that distance or that error is. For instance, suppose I use 0.3 to approximate 1/3. Well, then how far is 0.3 away from 1/3? Now on a graph, say if that's 0 and that's 1, 1/3 would maybe be right there. And 0.3 is going to be right here. So this gap right here, that's the distance between 1/3 and 0.3. And we could find that distance by simply subtracting 0.3 from 1/3. So if we change them both to fractions, we get this situation. And then we're going to have a common denominator of 30. And so we'll have 10/30. See, if I cancel the zeros, I'd still have my 1/3. Minus take 3 times this to get the 30 in the denominator, and I get 9/30. So I get 1/30. 1/30, or I could say, I could rewrite that as 3 times 10 to the first. Or I could even write that, if you use your calculator and do 1/30, you'd see it's the repeater itself, this repeater. Which makes sense, because if 1/3 is 0.3 repeating, then, and there's 1/3, and I take that 1/3 times 10 to the negative 1, I'm simply moving this number, this decimal over, so I get 0.0, whoops, 0.03 repeating. Okay, we won't go through that again. So let's take the next estimator. Like suppose instead of 0.3, we used 0.33. We add another 3 on to the repeating situation. So what are we going to have there? Well, again, just changing those to fractions, 33 hundredths. And our denominator will be 300, as you can probably see. And so we'll have 300ths, which is 1/3, minus, and then multiply 3 and 3 over 3, and we get 99. So we have 1/300th, or if we wish, 1/3 times 10 to the second, or if we wish, 0.003, and the 3 repeating. And similarly, let's just do one more. What if we were using 0.333, 33 hundredths? Well, to make a long story short, we'd have 1/3000th. You could figure that out using this same technique right here. Or 1/3 times, or 1 over 3 times 10 to the third, or 0.0003 repeating. Now, look what we've got here. We've got this pattern here. Oops, I kind of got out of line there. We've got kind of a pattern there, don't we? So couldn't we say that if we used 0.33 dot 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 3333 and say there were n digits of 3 here, and if we so we've got n threes, that distance, the distance to 1/3 should be 1, should equal 1 over 3 times 10 to the nth. Now, why is that important? Because we see that if there's always that distance between 1/3 and the estimator or an approximation, that there's no way that adding threes, repeating threes, can put this over 1/3. Can't be done. We're always going to have that space there. We could also get these same results by looking at 0.33333 and so forth, all repeating, and breaking them up. For instance, suppose we just broke this up right here at this point. Then this part, 1/3 equals 0.3 plus 0.03 repeating. And this number right here is then our estimator, or I mean our error. This is our error. And this number right here is our estimator. Because look, if we subtract the 0.3 from both sides of the equation, we get this same thing again, 1/3 minus 0.3. So then we're asking, how good of an estimator is 0.3 of 1/3? Well, it's this good of an estimator right there. There's our error. We could break it up again, like something like this. Let's break it up again, and this time break it up right there. So then I have 1/3 equals 0.33 plus 0.003 repeating. Taking the 0.33 across, then the distance between 1/3 and its estimator is 0.003 repeating. So this is the error when this is used as the estimator or the approximation. Let's do it again in the general case. Suppose we broke this up at n threes. We've got n threes there. Then 1/3 is 0.33 all the way to 3, and this is n of them, plus 0.000 dot dot dot, and there's n zeros, n zeros. If there's n threes right here, there's n zeros. That should have been a n. With the 3 repeating. So once again, here's your estimator. So, or I'm sorry, there's your error. So 1/3 minus the estimator, and there's n of these. The error is 1/3 times 10 to the negative n, or 1 over 3 times 10 to the n. So once again, we see we're always going to have an error. It's almost as if the 0.333 repeating never really reaches 1/3. There's always that error. Interesting thing to think about. You can see more interesting videos like this one at mrblocktutorsmath.com, or if you're having problems with your math and you need an online math tutor, you can sign up for a free consultation, and we'll get together on the internet on bit paper and work through some problems that you're having difficulty with, or some concepts that you're having difficulty with, and see how it goes. And maybe you'd like to hire me to help you with your math. You can also see a whole bunch of math videos that I did on Zoom at on YouTube at Mr. Block's math class. Remember, mrblocktutorsmath.com, free consultation, and you can find all the information at this site. Thanks. We'll see you later.